Hello, everyone, and thanks to Survive. Today, I know that Italian normally is not considered a low resource language, but I think that for some specific task, we don't have resources. And so today I want to talk with you about one specific task that is complex word identification. So we will have a little overview about this specific task and also how it is treated in Italian or not treated before this moment. And after that, I want to explain you how I implemented this system. So the dataset creation, the feature selection that is very important for this task, and also the training of our models. And I think the most interesting part of this presentation is the evaluation part, because we made two different evaluations. One with it's an internal one, and another is with an external resource that we create in this research, in this investigation. Complex word identification is a task of NLP that aims at identifying the words that are perceived like difficult for certain readers. So how can you understand by complex word? We refer to something very relative. So we have to ask to who is complex this word. And also we have to consider some specific parameters sometimes that are very related to the speakers. This task is very important, and this is demonstrated because now there are a lot of different shared tasks. Someone considered this like a standalone task because it's very important also for the development of systems that can facilitate language acquisition or for the creation of reading tools. Indeed, the complexity is very important also for readability, like we saw this morning. And also it is the first step of the pipeline of lexical simplification. And so it's very important because the first things to simplify something is to recognize that something is difficult and have to be simplified. When I'm a little bit off topic in this section, because when I talk about a word, I mean only a single lexical item. So I will not rate about multi-word expression because all the situation is a little bit more complex in this case. And for me, it's very important that you remember this information because complex word identification can trade in two different ways. The first one is the more simple one, and is a binary classification that consists in identifying and label a word as simple or complex. So it's totally binary. The second approach, that is the one that now is more used, is called the lexical complexity prediction, and is a classification that is continuous. So a word receives a value that goes behind the 0 and 1, and it's a continuous value, so it's not binary. In the Italian language, to the best of our knowledge, this task is never being studied or systematized. Indeed, it's very common, I don't know, in English, in language like English, or in Japanese and Spanish, but other languages is not considered too much. And I think this is by two main reasons. On one side, I told you before that we don't have specific resources for this task. That normally means that we need dataset with human evaluation because complexity prediction is very relative. And so we need a lot of annotators and for this type of task. And another, I think that a lot of very good linguists that also work in lexical simplification or in general in textual simplification consider our basic vocabulary of usage like enough to recognize if a word is simple or not. What is the meaning? That during the simplification, all the words that were included in this very important resource are considered like simple. All the ones that are not included are automatically complex. But the situation is a little bit more complex than this, because if you think about the word abolizione, that is like abolition, it is not included in the resource, but we have the verb, I don't know how it's in English, abolire. Yeah, abolish. And so abolire is considered like simple, but abolizione like totally complex. This is strange because we know that also with morphology, people can decode the information sometimes. So we try to to build a system with machine learning. And so we had to create, like first things, a data set. Unfortunately, the approach that we used in this investigation is dictionary based. Why unfortunately? Because for sure we know that also the complexity of a word is connected to the context of the word. So using a dictionary approach is a little bit limiting, but we think that we have to open this topic. And also this system help us to create the first resource that can be really used for lexical simplification pipeline in Italian. So we will see that we created the data set, but also the choice of the words considered like simple or complex is very, very difficult, because one of the main challenge is about what is complex in a language. So how can we define the complexity? The second step is the identification of some linguistic features that correlate with the perception of complexity of the speaker. And in this case, we consider a normal speaker, so not a speaker with some disabilities that have another treatment, and we need to consider very specific parameters. And after that, we try to training very different, not very configuration of parameter in the same system. For the dataset creation, so we decided to build a list of words, but we didn't know to influence with our bias the choice. And also we don't want to use the frequency like the unique parameter, because in all the previous studies, the frequency was the only one, but also in literature, there are a lot of literature that say one parameter is not enough to define anything. And so we were trying to think, how can we, what criteria we can choose to select some words in the more objective way we can. And so the things that we thought was about the common European framework of language. And so we decided to consider like simple word, the first three levels between A1, B1, because are the first words that everyone that started to study Italian learned in the first stage. And so luckily we have several resources in Italian strictly related to language acquisition. So there is the Merlin corpus that is like a collection of text produced by foreign learners. And we selected, it's very interesting because this corpus is produced by learners and there are a lot of metadata inside. And we selected the metadata connected to vocabulary range that has the specific label connected to the level of the framework of common language. There is Kelly, that is a kind of, all these resources are very, are built with some pedagogical workers that study all these things. And so it's very interesting also because also teachers help in the creation of these resources. So there are some resources that are built from the University for Range of Perugia. That is very important one. And we selected A1, B1, A1, A2, B1, sorry, B2 no, I made wrong. And the only resource that is not connected with the language acquisition is the last one, that is Varles, that I really want that this resource is bigger because it's very beautiful. It is now, it contains only 626 Italian nouns, but it's very interesting because it's there are a lot of lexical and sublexical variables connected to this because they build this with a lot of psychological, psycholinguistical experiments. So we have some metrics that are very important for our system. For the complex word, the discourse was a little bit more complex because we don't have too much resources like Italian L2 in this level, and also because all the resources that we have are based on pragmatics of the language. So it's a little bit more difficult to find some resources only connected to the lexicon. And so we found this dictionary that was built in 216. And it consists, it's very interesting resources because it consists of very rare words but also words that are technical words or words that normally you can use in a different register. And so we decided to take part of this complex word to include in our list to implement our system. So our final dataset consists about of 30,000 forms that are categorized as simple or complex. And after that, we started to think which kind of features we can search, which kind of parameter can help us to define the complexity. And okay, the literature presents a lot of different features very connected to complexity. And we have to choose the one that we can for sure implement. And also the only part in which we work more was about morphological features. Because, okay, some features are very common and are surface features, but in which the correlation with the perception of complexity is very strong. Because we know, for example, the decoding time is very important to understand if a word is very is known or not about the reader. So we consider some surface features like word length, syllable count, vowel count. We consider the frequency, but about two different corpora, because we thought that frequency is too much connected to the corpus that you use. And so we try to balance a little bit this parameter, if the word is stop word or not, and so see if it's very common or not. The number of senses was extracted with the Ital WordNet that is not so full resource, so there are some limitations. But for the morphological features, we implemented a convolutional neural network to segment automatically. And after that, we count the number of morphemes, the relation between the number of morphemes and the length of the word, and also the frequency of the lexical morpheme. So we used our model on the two frequency corpora, and we made the extraction of the frequency of the root. The evaluation of we try to implement a random forest algorithm. Okay, here I present to you only the random forest, but we tried very different classifier. And we decide to consider different model configuration. So we want to know, okay, frequency is enough to understand if a word is complex or not. Feature-based model that include all our model. We try to compare also with the only embedding models and with the total model that for sure is the one that works better. It's not a spoiler, but. So we trained our model, and for me, it's very interesting to see that frequency for sure has a strong impact in the prediction of complexity. So the important part is only to the problem is that when a word is zero frequency, the probability of that is a complex word is 1, so it's too much. So we have to balance this parameter with other one. I think it's interesting that the feature-based model is very similar to the embedding one, but we can understand which features impact on the complexity. So we made some correlation to understand which linguistic parameter correlates more with the complexity perception. And after that, the total model for sure is the one that works better. This is the internal evaluation. For the external one, I was the pleasure to work with a very big group because we built all together the multi-LS dataset. That is, we proposed a shared task about lexical simplification multilingual, and I built the Italian dataset starting from the model of before. The Italian part consists of 600 sentences with 6 target words. In reality, are 200 contexts, and so we have 3 words in each context. And the words were annotated with complexity and with, okay, substitution is for the other side of lexical simplification. In this context, we only consider to the lexical prediction. And so we have a minimum of 10 annotators, and we aggregate the complexity. And after that, okay, the annotator have this Likert scale to label that go between 1 and 5. 1 is very easy, 5 very difficult. We correlate the percentage of the belonging to our classifier is binary 1, but we have we are lucky, and we have also the probability of belonging to a word of one or the other class. And so we use the probability of classification of our predictive model with the aggregate human judgment. And so we saw that for the lexical complexity prediction, these are the evaluation metrics. And also our model was kind of good, but to understand if it's very good or not, we tried the comparison between the inter-annotator agreement and the agreement in our model. What is the meaning? Our model was like was the 11 annotators. So we compared the inter-annotator without our model and the inter-annotator with our model to understand how they are similar. And luckily, okay, the correlation is, we used the Spearman correlation because we were talking about ordinal values and very ranging one. So our system and the inter-annotator agreement fall within the same range. So we have for sure some problems because the value is not so high. So we need to improve for sure all these things, because I told you before, this task is a very subjective task. So we need more annotator also to have a higher inter-annotator agreement. For sure, the main limitation of this work is that is context agnostic, but this research that I present to you is the first one that we hope to create a bigger one, so increase the sample size, the type of texts that are inside, and also the number of annotators, in which that we can have a more clear situation. And for sure, it will be very interesting also introduce the multi-word expression, but I think it's another very big word. But I'm happy because we opened a topic in Italy that was never tried before, and I hope that could be useful also in here, because I think it's a very interesting topic and also with some social impact. So it's always something good. Thank you very much.